So now I want to give you some more rules on electron configuration. So, like I said in the last video, there's some rules. There are four quantum numbers. We're not really going to look at it in that way, but the first quantum number is the letter n. And n can represent any integer, 1, 2, 3, 4, 5, and on. Now the periodic table, like I said, bottoms out at n equal to 7, but theoretically n can keep going. Now, so this n is called the principal energy level. And like I showed you on the last video, that represents the periods going down the left-hand side of the periodic table. So after you've defined what n is, n can be broken, the principal energy levels can be broken up into sublevels. So when n is equal to 1, okay, there's going to be one sublevel, and that one sublevel is going to be designated by a small s. When n is equal to 2, there's going to be two sublevels, and those two sublevels are going to be the s and then the p, small p. When n is equal to 3, there's going to be three sublevels, which are going to be the s, the p, and the d. N equal to 4, you probably figured that out, there's going to be four sublevels. They're designated as S, P, D, and F. Alright? So now, once you've defined what the sublevels are, another rule is that the sublevels are broken up into orbitals. So if I have these sublevels, so the first sublevel I talked about was the S sublevel. S sublevel has one orbital. The P sublevel has three orbitals. The D sublevel has 5 orbitals. So I want to do that in different color. Has 5 orbitals. And the F sublevel has 7. Mess that up again. Okay. Has 7 orbitals. Now, each orbital can hold a maximum of 2 electrons. Alright, so each orbital can hold a maximum of 2 electrons. So it can hold 1, or it can hold 2, depending on however many electrons there are. Alright, so this might seem a little confusing, and yeah, probably is a little confusing. But we'll get to where we can sort of make an idea, a rough sort of estimate as to where these electrons are going to be, which turns out to be pretty valuable. So let me just give you a picture, an idea of what an S sublevel and its orbital is going to look like. So here's an S sublevel. Okay, since the sublevel is S, there's going to be one orbital. Okay, now on a Cartesian plane, an XYZ axis, this one S orbital is going to be a sphere, and that's kind of the classic idea of what an atom's going to look like. Okay, it's just this round object. Now, in that, there can be two electrons. There can also be one electron. You couldn't tell that there's one or two just by looking at it, because the electrons are acting as waves now. But in that area, there can be either one electron or there can be two electrons. And when I go to a p sublevel, things become a little more complicated, because p's have three orbitals. And the three p orbitals on a Cartesian plane are going to look like this. I'll draw the three. Okay, so I have three orbitals. One of them is kind of a dumbbell looking diagram that is oriented off the y-axis. Another orbital would be the same dumbbell thing off the x, and then one off the z. Now, just like in the S, these orbitals can hold either one or two electrons. And if you remember back on the periodic table when I said there was an S block, the S block is going to be two positions, two elements. Well, those two elements hold the two electrons that are going to be in the S orbital. P's, in the P block, there's 6 positions. Well, that accounts for the maximum 6 electrons that can be put in the P sublevel. Now, I'm not going to draw a D. I'll have pictures for that because it's really complicated. And F's are really complicated. I'll show you on the computer what they look like. But now I want to talk about some rules for how these orbitals all come about. One of them is, it's called Hund's rule. And Hund's rule works like this. Hund's rule states that when you are filling up a sublevel, and let's say we go to a P sublevel. P sublevel had 3 orbitals. And I'm going to now draw those orbitals in a different representation as a box. And these are called orbital diagrams. And I'll do it something like that. So those 3 orbitals now are designated with those 3 boxes. And Hund's rule states that orbitals are going to fill up separately with electrons first and then double up. So the filling order of a sublevel would be 1 electron, 2 electrons, 3 electrons, and now I start doubling up. And the electrons, in order to be in the same space, same orbital, have to have opposite spins. I didn't really draw that all that great because these electrons kind of look like that. But it's an arrow going up and an arrow going down. So next video I'm going to talk more about these rules.